Algebra 1 students. In this video, we are going to take a look at the last activity for lesson 15. Okay, so once again, we're continuing to build on what we got to do and what we got to see in this lesson from the warm-up, where we were just adding numbers that were the same or combinations of numbers that equaled the same thing on both sides of an equation, and the equation still turned out to be true. We discovered that if you have an equation that's false and you add it to an equation that's true, you're going to get an equation that's still false. Okay, then in 15.2, you got to explore what happens when you take the same thing we're talking about. We've been talking about it for the past several lessons. Related equations that talk about the same thing, okay? With a teacher buying calculators and measuring tapes for her classroom. So now we're going to take it out of the real world and go back to just some mathematics and some numbers. So here are 4 systems of equations, and I'm not going to tell you how to solve them. I'm going to let you choose the method that you would rather use, okay? It would be nice if you would use algebra by elimination or substitution, but you can also graph these, okay? And so I'm not going to, I'll show you one of them, but then I'm going to pause the video, give you time to work through the other 2, and then I'll pick up the discussion by looking at this last one, and then we'll synthesize the lesson. Okay? So if you look at this system, you can see you've got a positive 2x and a negative 2x. So when you add these 2 equations together, you're going to cancel out your x's, right? Which is going to make it pretty easy to solve. Okay? So let's see what happens. I've got 2x minus 2x, that gives me 0x. And then 3y plus 4y is 7y. Okay, and that equals 7. Okay, well, this is pretty easy. All I have to do is divide both sides by y. Divide both sides by 7. So 7 divided by 7 is 1. So y equals 1. Okay? So now that I know that y equals 1, I can just go straight back into one of my original 2 equations, drop that 1 in for y. Okay? So you can see I've got 3. This is just going to equal 3, right? 3 times 1 is 3. So in order to get x by itself, what do I have to do? I've got to subtract 3 from both sides. So 7 minus 3 is 4. Okay, so I've got 2x over here equals 4. Divide both sides by 2. X equals 2. Okay? So you walk through the next 2 and go ahead and solve them. All right, and you get to choose how you're going to do it. And then I want us to revisit this set. Okay, so I want you to take a look at D. Let's look at D. So can you add these equations together the way they are right now and solve it? I hope you said no, because you can't. Okay? Not in its current form. So this is hopefully making you think about, hey, wait a minute. I've been able to solve all of these systems that we've done so far either by adding or subtracting the two equations together. Either that or I've had to graph. So can we solve this system with elimination just because we can't add them together in their current form? Well, we're going to learn about that in another lesson. Okay? But I want you to think about it. All right? So let's go ahead and wind up this lesson. Let's synthesize this lesson. Okay? So what happens if we add or subtract these three? Okay? You can solve them. And all three of them had solutions. Okay? So why were we able to solve these three by elimination, but not this one? Hopefully, you said, because these are easy, right? In all three of these, you had coefficients of one of your variables that were opposites of each other and would cancel each other out when you added them together. Okay? Which only left you with one variable, which is what you can solve for in mathematics. Okay? And what features were in the equations? Oh, that's the feature that we're talking about. What features were in the equations but not in the last one? Opposite coefficients or coefficients that were identical. So these two you could add together, right? This one you had to subtract. But you still got the right answer. Okay? All right. So let's talk about this last piece. Okay? So is there a pair of x and y values that make both of these equations true? And the answer is yes. Okay? There is. All right? And so they ask you another question. Why is it okay to add 2x plus y to one side of the equation and add a number 7 to the other side? Why is that okay? Okay? It's okay because 2x plus y equals 7, right? I mean, it says it right here. So therefore, we can add this to this side and this number to this side. Okay? And we still get a true statement. All right? And once you add these two together, go ahead and try the pair 2 and 3. And I think you're going to discover, just like the teacher with her calculators and measuring tapes, that it's going to work. Okay, because they're equivalent. All right. So now what if we added 7 to the left side of the equation and 2x plus y to the right side? What would that new equation be? And would you end up with something that's true? Okay, so let's go to Desmos and I'm going to demonstrate this situation for you. Okay, so let's finish this up. So here's your first equation that they gave you. Here's the second equation that they gave you, the black line. You can see that the solution is 2 and 3, all right? Here, this red line is when you added the two equations together. The new equation, look at that, runs right through that point, okay? And here's what happens when we did it backwards. This is so cool to me to be able to show you this, okay? That it doesn't matter whether we're adding variables or numbers. If the quantities are equal, as long as we do the same thing to both sides of the equation, we end up with a true result. We end up with a solution to our system. I hope you found these videos helpful. I know they're long, but I'm just trying to take my time and go slow and give you lots of time to access the information. So thank you for listening, and I'll see you next time.